So in this example, we're going to do some more data calculations. I'm actually going to introduce an array function, which is something that we could have used in the CEO problem, but I showed you a way of filtering the data. This time I'm going to show you something a little more complex, but we'll talk about that here in a second. So what we're going to do is we're going to calculate the total income per house. And so for each of these 4 locations, we're going to calculate out the 90% confidence interval for the mean. The next thing that we're going to do is we are going to do the 90% confidence interval for the difference between the mean total of annual income for the first and the second sectors of the community, so the southwest and northwest, and then we'll do that for their location pairs, and then what final conclusions can we draw. So if we go to the data, we have a bunch of data about the house. We have the household, the family size, first and second income, and so we have some monthly payments, income, debt, and all that. So right off the bat, the first thing I want to do is I'm going to just add some range names for this data. And I think this will probably be the only range names that we end up using, top row, because we have these grids in here that we are going to end up filling in. And so what I want to do is I'm going to calculate out the total income. So we're just going to sum the first and second incomes together to give us the total household income. And so we will drag all of that down. Okay, and so now what we're going to do is we're going to start putting all of this data together. And so we're going to be using a bunch of functions that we already know. And so we have locations listed there. So we're just going to go right to it. So sample size, we're going to do a count if. Remember, it's going to count if we meet a criteria. And I hit the wrong button. So count if. And so what I want to count is the number of certain houses in that location number 1. So we're going to be counting down the location column, and I want to count everything that is 1. So that would be N6 here. And then I will close that up, so 129. What I want to do is I'm going to build down the first row and then just drag everything over. So we will set up those equations to make sure that we can do that. So the sample mean, we're going to use our average if statement, and we're going to use the same, first part's the same column, so we're going to use location. We're going to make the cut location 1, and then what do we want to average? We want to average total income. And so there we go. Range names in tab make this really quick. And so we're averaging out 73,000. Now, the next part, this is where we're going to introduce the new thing, the entire idea of array functions. We did an average if. There is no standard deviation if. So what we need to do is we're going to use kind of a workaround, which is called an array function in Excel. It allows it to work on multiple cells at the same time. And so what we're going to do is we'll start this out like it is a regular standard deviation equation, except right at the end, we're going to hit Control Shift and then Enter. And that's the important part. So the first thing, let's just build the equation. So stdev.s, because we're looking over the sample. Now, here's where one of the differences come in, is it asks for string of numbers. We're going to write an if statement in there. And we're going to tell it, we want you to run a logical test. And so what that test is, we want you to look at location. And if location is equal to location 1, if that's the case, I want you to spit out a value if true. And so that value if true is going to be our total income. We're not going to put a value for false, because if it's false, we just don't want it to do anything. Now, normally if I go and just hit enter here, what's going to happen is it's going to give me 29,000, and we're like, oh, that's great. That's not the actual answer, because it's not calculating correctly. So what we're going to do is, when we're going to hit Control, hold Shift, hit Enter. Now notice two things. One, the number changed. It went to 28,509. That is the correct value. The other thing you'll notice, I've got these brackets up here. These brackets have told me that I am dealing with an array function. So we've calculated it with an array, and it's doing a lot of different things. So what Excel is actually doing is it's doing this logical test and then bringing out this total income and then dropping it into the standard deviation equation. It's kind of a kludgy way of doing things, but this is the workaround. This can happen. This works a lot in Excel. When you get functions where you want to do these layered calculations, array functions are great to use. They are draggable and with the index, so that is also great. So we're going to be able to drag this straight across. We could have done this in the CEO example, but I filtered the data a little bit instead. And there we go. So that is how we work things. Okay. So the standard error. So we want to find the standard error of the mean. So how do we find the standard error? Well, that's just the standard deviation divided by the square root of the sample size. So we'll go to our standard deviation, and then we'll divide that by the square root of our sample size. And then it'll give us a standard error of 2,105. So we're going to do our degrees of freedom. What is our degree of freedom? That's the sample size minus 1. And so our multiple, once again, this is our t-test. So we're going to run our student t-test here. So equals t dot, we'll make sure that we grab the two-tailed version, so we're getting both sides. So the probability, we'll use our alpha value, so 1 minus our confidence level. And then we're going to divide it by our degrees of freedom. Sorry, not divided by. We're going to enter our degrees of freedom. And so there we go. There is our t-value. So we are ready to go. We are just now going to do our confidence interval. So our lower limit, that's where we're going to start. And so we will start with our mean. And then we are going to subtract from that our alpha value. I want to plug in, actually, I don't want the row to change on that because I always wanted that to be row 12 because I am going to drag that down. Since I'm not naming it, I got to be a little bit more careful with this stuff. And then I'm going to, oops, what did I do? I added an extra thing in there by accident. Now I want to multiply that by the standard error of the mean. And once again, I am going to put a $sign in there because we're going to drag that down. So the lower limit for our total income, 69,000. I will drag that down. I am going to make a couple changes here. And actually, let's go back and fix this. I didn't want the row to change. I made that mistake because I should have gotten the exact same number. I'll drag that down. Got the same number, and I will just switch this to positive. So there's my 90% confidence interval. Okay, now I'm going to drag everything over. This is the one that we want to pay attention to because we want to see that it drags. So I'm just going to grab this, drag all this all the way over, and we can see that this array function went from cell to cell. And that's what's great because they are draggable. You have to be just careful with these, control, click. Because if I go on that, I click on that and I hit enter again, notice it is no longer an array function. So you got to be careful. Control shift and then enter. Oops. So I got to highlight it first. Control shift enter. There we go. It's back to an array function. Like I said, it's a little bit of a workaround, but it does work. And it's going to be handy when we get down to this table. What I showed you before when I just filtered the data, that was great because there was only 2 columns of data. This gets a little more complex because we're going to be dealing with so many more, especially now as we're going to do these confidence interval differences between these pairs of locations. And that's what we're going to do in part 2.